My name is Mary Elizabeth Davis, and I went to the public lecture titled "100 Years of Einstein's Gravity" because I have always found conversations about the universe, space-time, and gravity's effects to be extremely interesting. There were two speakers at this lecture. The first was Laura Catanati, and she talked a lot about detecting gravitational waves. She showed us different projects and facilities around the world working to detect them. Gravitational waves are ripples in the fabric of space and time that are produced by violent events in the distant universe. These ripples travel towards Earth, and if they can be properly detected, then we can learn what is in the universe and how things like black holes, stars, and planets interact with each other. I found it particularly interesting when she talked about the collision of two black holes. Many computer programs can model this for us, and it looks really quite cool, such as this image. Black holes are extremely massive and very dense, and when they collide, they'll get closer and closer together until they can't escape each other's massive gravitational pulls anymore, and they will eventually become one. This would be an extremely violent collision, and the energy emitted from the collision would be so great that it will send ripples through the space-time fabric of the universe. It's important that we detect these gravitational waves because that is a fundamental point in Einstein's theory of general relativity, which would prove Einstein's theory even further and increase our understanding of gravity. The next speaker was Desiree Shoemaker, and she continued to talk about this topic of black holes and collisions and detecting gravitational waves. But she also related this to students that were in a Physics 1 class and learning about energy for the first time. She explained that waves can create a lot of energy, and now that they are starting to detect them, we are at a very unique time in science as we witness changes in our understanding of gravity. One thing I found particularly interesting was that the small effects of gravity, such as if you are at the top of a building, you're going to age more than someone at the bottom of a building because of your position relative to the gravitational field in space-time. After attending this lecture, I watched the movie Interstellar because both of the speakers said that it brought up some very interesting topics about space-time and gravity. And then, after watching this movie, I did some research on how you would age in different worlds. If I lived in Mercury, I would be 80 years old, but if I lived on Jupiter, I would only be about 1 year old. That is crazy. This is because planets are held in orbit around the sun at different magnitudes and thus have different radiuses of orbit and different rates that they travel around the sun. While the Earth takes 365 days to make one circuit, which would make me 19 years old, the closest planet to the sun, Mercury, only takes about 88 days. And poor Pluto, so far away, takes a whopping 248 years for one revolution. There is so much interesting research on the effects of gravity, and I hope I can keep discovering more. Thank you so much for listening.